Hello everyone. This video is going to be a quick video to show you the equivalence of equation of motion from the Newton's law and equation of motion in the previous 1D and 2D kinematics. Okay, because the last video I showed that this is the I also call this equation of motion. And this video I try to relate its radial equation motion as the equivalent to previous chapter. Okay, and because let's just do the very quick demonstration. So let's keep the problem simple. Okay, suppose I have object. Okay, and we just stick with 1D motion. Okay, because it was just very quick demonstration. Okay, and acceleration is g point downward and x, and we define the downward direction is x direction. Okay, so let's say the Newton's second law says F equals to ma. For simple case, F equals to ma, and a is a derivative of velocity with respect to t, and v is also the derivative of position. Velocity also derivative position, so it's finally will become the second derivative of the position. So, and for this problem, we just say the force, the only force, is, yeah, I just say the gravity. I just pretend is a normal acceleration. Okay, so the only force is the gravity. So F is acting on this object is mg, and equal to ma is m times d squared dt squared. Okay, and we divide together, and we will obtain an equation like this. And this is called differential equation. Yeah, I know most of you is not able to solve it, so I just do a demonstration. Okay, I think I still need to show you. Okay, because sooner or later you will learn this, maybe next semester in calculus class. So for this type of differential equation, we can solve it very simple way. Okay, so in a simple way. Okay, because we just do the integration. Okay, we do integration. Okay, when we want to solve this this very simple it's a very simple differential equation, we just use integration. So we just do the integration. Okay, integration, and with respect to t, and both sides I do the integration. And the initial time is 0, and at the later a certain time I call it t. Okay, that's the initial is 0 and it's t. Okay, when I do the integration for left hand side, you just watch me. Okay, I know you right now you cannot understand this. Just watch me. This is equal to the ds dt at time t minus dx dt dt at the time 0, and the right hand side is the gt. Okay, so and then we check the definition. Okay, this is just the velocity, right? This is also velocity, but it's velocity at time t. This is velocity at time equal to 0. So this equation will become, okay, v at time t minus v's initial velocity. Initial velocity we set the vi, and this is gt. So you will get v of t equal to vi plus gt. Okay, look very similar, right? It's just like the constant acceleration. Yeah, we are dealing with constant acceleration. Let's make example simple. Okay, so I still remember the equation of motion for one dimension, vi equal to vf plus a times t. Yeah, similar, right? Okay, let's keep doing this. Let's keep doing this. For further, let's doing this for further. So the velocity is the derivative of position with respect to t. So it's equal to vi plus gt. Okay, and then this also differential equation. This differential equation is very simple. So let's do the integration again from both sides and 0 to t, 0 to t, and dt and dt. Okay, really, okay. What did we will get? For left hand side, I will have xt minus x0 x at time 0. Okay, I should write down maybe x of t minus x times 0. Then equal to this right hand side integration actually is easy. Right now you may not understand, but actually it's really easy after you learn the calculus. So gt squared. Okay, so we get another equation of motion. And let me just write down, you will get x of t, and the position of at time equal to 0, let's just say it's xi plus vit plus 1 over 2 gt squared. Yeah, look very similar, right? Look very similar, right? At the 1D kinematic, I said xf equal to xi plus vi times t plus 1 over 2 gt squared. That g is at squared. But never mind. It should be a. Okay, so that's why I tell you that Newton's second law of motion is equal. This is equal equation of motion. It's more general form of equation of motion. In this class, I will in the later of this section I will use this. I will use this a lot. Okay. So after this section, when I call equation of motion, I would say after I introduce Newton's law, I would say equation of motion is this. Okay, equation of motion, and then a is equal to the second derivative with respect to time. Okay, let me write it down. I should write it down. Okay, what is equation of motion? This is called equation of motion. Okay, f equal to m times the second derivative of x with respect to time. This is called equation of motion. Okay, we'll use this a lot. Okay, in this class. Okay, so let's just show you the previous 1D kinematics. The equation of motion is equivalent to the differential, this differential form. Okay, this is also equation of motion, and this is more powerful than the previous this equation of motion. Actually, this equation can derive can obtain this equation of motion and this equation of motion. You just saw it. It's more original. It's the original equation of motion. Okay, so this is just a very quick video, and I will stop here and see you in next video. Bye bye.